we're gonna finish up section 6.1 on those laws of sines. So previously we sat there and we're looking for sides and angles by using all those proportions. Today we're going to look at this formula and some variations of that formula, where our A is finding the area of a triangle. How cool is that today? Woo. All right. Not exactly. So the reason why we use those laws of sine just previously in that last section was because the triangles we were looking at, they were special triangles. They were those oblique triangles, which means that they didn't have right angles, right? So kind of the same is going to apply on today. We're going to sit there and find the area of triangles, but we're going to find the area of oblique triangles. So these guys are not going to have 90-degree angles. Okay. So I'm going to go through, and you don't have to write this down in your notes if you don't want to. I'm going to give you guys an oblique triangle, and then we're going to go through, like, if you were still stuck in Algebra 2 or before you got this lesson, how you would have to find the area of that triangle. And you could still continue to go through the same process, but I think maybe today we might be learning something a little bit quicker, possibly. Another method, right? So my triangles are, you know, never drawn to scale. I just kind of draw something funky up there. So here's my oblique triangle, right? And in my oblique triangle, I'm going to say, like, this guy is 62 degrees. I'm going to say this side of the triangle is 10, and this bottom side is 24. And I want to find the area of this triangle. So up to this point, we do know a formula to find the area of a triangle. Anybody remember that formula?
Base times height divided by 2.
Yep, base times height divided by 2, or 1/2 base times height, right? And what do we know when we use this formula? There was something, like, when it came to that base and that height, we had to know something very special about that base and that height. It had to make a 90-degree angle, right? It had to be perpendicular in order to be the base and the height. And when we look at our triangle right now, do we have a right angle the way that it is? No, we don't, right? I mean, technically it possibly could, but it's not, right? But it's not given to us.
It's not drawn that bad.
Pardon me?
It's not drawn that bad.
Well, it's pretty bad, let me tell you, right? it adds up to 180, that's about all, right?
The top is pretty close.
Pretty close, but close doesn't count unless you're, you know, whatever that thing is, horseshoes and horseshoes. It only counts in horseshoes, and we're not playing horseshoes right now. So if I were to give you this problem like last year in Algebra 2 or something, I'd be like, well, what we could do is we could drop down a perpendicular. We could start at this angle and we could drop down and we could make a 90-degree angle. And then now we have two smaller triangles. We have this triangle and we have this triangle. And if we can find that height and we can find these two bases, we could find the area of both of those triangles and add them together, right? So we know trig, and we know when it came to that sine, cosine, and tangent that it had a lot to do with those 90-degree triangles. So we could use trig identities in order to figure out this height, right? Because from this angle, that would be the opposite, and this is the hypotenuse, right? So opposite over hypotenuse is the sine. Good job, right? So to find that, I would have what? You know, we'll go with this color. The sine of 62 equals opposite. What do we want to call our opposite? Want to call that guy x? I'm good with x. X over the hypotenuse, which was 10. Makes you warm and fuzzy. We threw them into fractions. We cross multiplied, so 10 times the sine of 62 equaled x. We would plug that into our handy dandy trusty little calculator, making sure that it was in degree mode because they gave us degrees. And that little guy is going to pop out and we're going to get 8.83, right? So now I know that that height is 8.83. So to find the area of that triangle, 1/2 base times height, well, I have my height, but I still need to find my base. So you could use trig identities again, but I'm just going to use Pythagorean Theorem just for the fun of it, right?
Wouldn't the 24 be the base?
Of the entire triangle.
Aren't we trying to find the area of the entire triangle?
Well, that's
Yeah.
what I agree.
Right. You could do it that way. Yep. Yep, yep. And then, right? I'm doing it the long, hard way to show why you guys want to do it the other way. And then if I wanted to use Pythagorean Theorem to find this little side, I could have, I don't know, let's go with a squared plus 8.83 squared equals 10 squared. So I think we get like a squared equals 22.0311. Take the square root of both sides. A is going to be 4.69, right? And it's got to be the positive 4.69 because we're talking about a distance. So we know this little guy is 4.69. So now you can find the area of that triangle, right? So you'd have area equals 1/2. Our base would be 4.69. Our height would be 8.83. Bless you. Plug that into our handy dandy little calculator. And we end up getting, I think it's like 20.706. Right? And then if we wanted to find the area of this triangle, kind of that same thing, right? 1/2 base times height. 1/2. Our base, that would just be this little piece. So if the whole thing was 24, we would subtract that 4.69 off of there. And I think we end up getting like 19.31. Yeah. Times that by the height of 8.83. Oops. Multiply those little guys together and then we get 85.254. If we add the area of the two small triangles together, we get a total area of, 105.96 meters squared. Or you could have just done it once and did 1/2 the height times the entire base and you'd get the same answer, right? Yep, yep. So that's
Correct.
one way, two ways of sitting there finding the area. Yeah. So the other way we can do it is by using our law of sines. And so let's go, and then we're going to do that same problem again.
Will you go up for 1 more second?
Oop.
Please.
Do you just need the total? Okay. You can add those little guys together. All right. So when it comes to the law of sines, if we had any oblique triangle, my perfect little drawing, right? Label your angles however you want to label them with your capital letters. Those opposite sides correspond to those angles. Those would be A, B, and C, right? So our little formula for the area of a triangle. Oops. So area is going to equal 1/2, and I'm going to go with BC times the sine of A. And we'll talk about that here in a second. So when it comes to the formula, you have one angle. We got one angle, and then we have these two sides. So if I'm looking at angle A, my sides were B and C. So those are the two rays that make up the angle. Does that make sense? So, and we're gonna list out, there's technically like 3 formulas, and it just depends on like which angle they're talking about. So if they're talking about angle A, the two sides of the triangle, or the two rays that make up that angle, is C and A, right? If we're talking about angle C, it's gonna be that side A and that side B. Okay. So then you would have the area of 1/2. Which two sides you want to go with?
CA.
C and A, right? So I'm going to go with AC just because it's alphabetical, right? Times the sine of then what angle would that make? Makes B, right? And then the other one would be 1/2 of AB. And that would give us the sine of C, right? Does that make sense? So, and those are all on your reference sheet, but a lot of times I just remember it because I'll change the letters, you know, of the triangle. It's always whatever angle in the sides or the rays, right, that technically make up that angle, right? So if we go back to the problem that we just did previously, I'm going to draw it right here. What did I have? This was 62 degrees, this was 10, and this was 24, right? And if you wanted to, you could go ahead and you could put ABCs on this, and you could put them in whichever order you wanted to put them on. Like, where do you want to put A? Top, left, or right? Left, yeah. You guys are so happy. Where do you want to put B? On the top or the right? Top. You guys just change things up on me all the time, right? And then if you filled in the sides, this would be A, this would be our B, and this would be our C, right? So out of those 3 formulas, technically, which one are we using?
A 1/2 BC sine of A.
Yep, we're using that first one, right? And then so we're just gonna fill that in. So we got area equals 1/2 BC sine of A, right? 1/2 B is 24, C is 10, times the sine of 62. Right? Making sure our calculators are in that degree mode. And we're going to go through and plug and chug. And we're ended up getting the area is 106. So did we get the same result? Right? We did it 2 ways. There was another way to do it, right? If you just wanted to do the one whole triangle. But so, like I always say, there's more than one way to skin the cat. There's more than one way to kind of go through the problems. Is this one a little bit more efficient, a little bit more quicker than the other way? Absolutely it is, right? So, but do you have to use it? You do for like the homework, right? Just so that I know that you've practiced how to do this other method. But on the test, if it tells you to find the area of the triangle, you got options. Like I don't know how you're technically figuring out the area. If you wanted to do it with the laws of sines, or if you wanted to break it into little triangles, or however, right? Give you guys all kinds of options, right? One more quick example. Sometimes they won't give you they won't draw out the pictures of the triangles. They'll just tell you what they want. They want you to, you know, find the sides, or for us for today, they want you to find the area of a triangle. And they're going to give you C equals 135 degrees, A equals 8 meters, and B equals 12 meters. If you need to draw out the triangle, sometimes when it comes to the area, maybe you don't have to draw out the triangle, but if they only give you like the 3 pieces and they tell you to find out the sides and the angles, sometimes it's easier if you draw out the triangle. Does the triangle have to be drawn to scale?
Yeah.
No, I've proved that, right? So here we go, right? Where do we want to put C? Like the left, the middle, or the right?
Middle.
I figured you would pick that one, right? So that was our 135. Where do we want to put A? Left or right?
Right.
Right? And this would be our B, right? Yep. So what value is going to go right there? 8, 12, or nothing? 8, yep. Which one's going to go up here? 12 or nothing?
Nothing.
Nothing. Which one's going to go here? Whoops. Go away. There we go. Which one's going to go here?
12.
The 12, right? If you need to draw it out, right? Or we could have looked at this and said, oh, they gave us the degree, and then they gave us those sides that are going to make up that angle, right? Because they're not the same letter. So we have what the area equals 1/2 AB sine of C. Plug and chug. A equals 8. B equals 12 times the sine of 135. Plug that little guy into your calculator. If I did it right in my head, we get a 33.9 meters squared. If I carried the 2 properly, that is. Right? Only other thing to keep in mindful, and it doesn't work. Oh, yes, sorry. Yes.
For tests and stuff, are we still required to put like the amount, like the meters squared, for it to count?
Yes. Yes. Come on now. You guys are the fancy kids. You guys know how to put meter square on there.
Yeah, if we're so fancy, then we just don't need that extra stuff.
You gotta show me how fancy you are. You know. Yep. The only other just kind of piece of advice to always make sure you have in the back of your head, like when you're figuring out all of the angles and all of the sides, if I gave you a triangle, not drawn to scale, of course, and I said this was 40 degrees, I'm gonna go 40, and then this was 60 degrees, and then I was like, this is 5, this is 9, and this is 2. There's always that little correlation. Technically we could figure out that other angle. That other angle is going to be 80, right? I try to keep it fairly simple, right? And remember, there's that whole correlation between sides and angles, right? That side or that angle changes that opposite side. So if I have 80 degrees as my biggest angle, then that opposite side has to be my longest, right? If this guy is my smallest angle, this guy's got to be my shortest side. So if I were to come up with these answers, is this a viable triangle? No, it's not even possible, right? It's not possible to have those measurements in this triangle. So just keep that in mind when you're working on some of those problems where they want you to find sides and angles. Always kind of look at it and double check and be like, is this possible or is this not possible?
Disobeys the laws of existence.
Right, exactly. Sound good? Alright. So I don't have a whole lot of problems for you guys.